This lesson is a warm-up to section 7.4. We have to do a review of simplifying radicals and performing operations with radicals that will be used within section 7.4. We want to simplify radicals. Remember, this is our square root symbol, and we want to take the square root here of 36. Since 36 is a perfect square, the answer is 6. 6 times 6 is 36. Therefore, the square root of 36 is 6. Here, what is on the outside of the radical is just going to be multiplying what comes out of the radical. Here, I have the negative square root of 16. Therefore, the square root of 16 is 4. And 4 times a negative 1 is a negative 4. Here I have plus or minus the square root of 144. The square root of 144 is 12. 12 times a positive 1 is 12, and 12 times a negative 1 is negative. So therefore, this is still a plus or minus 12. Here I have the square root of 24. It's not a perfect square, but I still need to simplify the problem. So what I'm going to do is rewrite the radical, and then I'm going to break 24 into two factors, one of which must be a perfect square. The factors are 1 and 24. 1's a perfect square, but that's not going to get us any closer to a solution. The next one would be 2 and 12. Here, I still don't have a perfect square. Another one would be 3 and 8. Again, I don't have a perfect square. But the next one I can choose is 4 times 6. 4 times 6 is 24. So I haven't changed my problem at all. Now I just simplify this radical. And the way I do that is I take the square root of 4. That's a perfect square. The square root of 4 is 2. It comes outside the radical, and I just rewrite what stays inside. And what stays inside is the one I didn't cancel. Now, another way to do that is to use one of the other two scenarios. For example, I can choose 2 or 12 and 3 and 8. If I choose 3 and 8, what I would need to do is just break 8 into another set of factors. Therefore, it'd be 3 times 2 times 4. And again, the square root of 4 is 2, which would come outside the radical, and 3 times 2 would stay in, which is 6. And again, I still get the same solution. On my next problem, I have a negative square root of 98. Here, I'll bring down the negative, rewrite the radical, and I'll write this as two factors, one of which is a perfect square. That would be 49 and 2. 49 times 2 is 89. The square root of 49 is 7. 7 times a negative 1 is a negative 7. And what stays in is 2. Negative 7 square roots of 2. Here, I have a negative square root of 48. The easiest way to break 48 up is to break it into factors such as 16 times 3. 16 times 3 is 48. 16 is a perfect square. The square root of 16 is 4. 4 times a negative 1 is a negative 4. Square roots of 3. On that problem, I could have broken 48 into different problems. For example, I could have had the square root of 4 times 12. That would give me, when I take the square root of 4, a negative 2 square roots of 12. But then I'd have to break up 12 into two factors. Negative 2 square roots of 4 times 3. Then the square root of 4 is 2. 2 comes out. A negative 2 times 2 is a negative 4 square roots of 3. Again, I end up with the same solution, but this is just quicker. Now I have the same situation as I had before, but now I'm going to have a coefficient other than 1 or a negative 1 in front of my radical. Again, I want to follow the same procedures, which means I'm going to bring down my 3, rewrite my radical, and now I have a number that's not a perfect square. So I need to find two factors, one of which is a perfect square. So here, the easiest way is 16 times 2. The square root of 16 is 4. 4 times 3 is 12. Square roots of 2. My next problem, a negative 4 square roots of 40. I bring down my negative 4. The square root of 40 is not a perfect square. I break it into a product of its two factors, one being a perfect square. I'll pick 4 times 10. The square root of 4 is 2. 2 times a negative 4 is a negative 8. Square root of 10. It looks like 10 can break up into two more factors, and it can. 1 and 10, that's not going to help us. 2 and 5, but 2 and 5, neither of which are perfect squares. So this is our simplified answer. Next, I bring down a negative 4/5. The square root of 50. That's not a perfect square, but two factors, one of which is 25 times 2. The square root of 25 is 5. 5 times a negative 4 is a negative 20 over 5. When I simplify, that's going to give me a negative 4 square roots of 2. Here I have a negative square root of 6 times a negative square root of 10. Two ways to solve problems like this. One, I could simplify each radical first, then multiply together at the end, and then see if I can simplify any further. That's not going to help us here because the square root of 6 and the square root of 10 are already simplified. In that case, what I need to do is to multiply our coefficients outside our radical, and then multiply inside our radical, and then simplify. Here, a negative 1 times a negative 1 is 1, but I don't need to write that. And the square root of 6 times the square root of 10 is going to give me 60. Then I simplify this value by breaking that into two factors, one being a perfect square. That'll be 4 times 15. 4 times 15 is 60. The square root of 4 is 2. And 15 stays inside. 2 squared is 15. Again, I could simplify each separately, but that's not going to help us, again, because each are already simplified the lowest terms separately. So then I have to perform 3 times 1, which is the coefficient here, which is 3, stays outside the radical. Multiply inside the radical, I'm going to get 28. Find two factors, one being a perfect square, bring down to 3. That's going to give me 4 times 7. The square root of 4 is 2. 2 times 3 is 6. And 7 stays inside, 6 square roots of 7. Here, what I could do is actually break this 8 into two factors and get 4 square roots of 3 times a negative 2 square root of 4 times 2. And bring down the 4 square roots of 3 times a negative square root of 4 is 2. 2 times a negative 2 is a negative 4 square roots of 2. Then I could actually multiply these two together and get 4 times a negative 4 is a negative 16. Square roots of 3 times 2 is 6. Again, I could have just multiplied them together and got a negative 8 square roots of 24. Then I could have broken that into a negative 8, two factors, one being a perfect square, 4 times 6. The square root of 4 is 2. 2 times a negative 8 is a negative 16. And 6 stays in the radical. Again, the same solution. This is usually quicker unless the numbers are large. Now what we're going to do is take square roots and have them squared. So recall from exponents in Algebra 2, I'm going to have the square root of 5 times the square root of 5. Therefore, the square root of 5 times the square root of 5 is the square root of 25, which gives me 5. So when I have a square root squared, what I end up with is what's inside my radical. That's if my coefficient is a positive 1. For example, if I do the same operation here, I'm going to have a negative 2 square roots of 25 times a negative 2 square roots of 25, which gives me a negative 2 times a negative 2 is 4. And 25 times 25 is 625. Bring down the 4, and the square root of 625 is going to give me 25. Therefore, our solution is 4 times 25, which is 100. I could have ended up in this same position because I know a negative 2 times a negative 2 is 4. The square root of 25 squared is what's inside the radical, and then 4 times 25 is 100. Either procedure will work. Recall, I can do the shortcut, which is a -3 squared, which is going to give me a -3 times a -3, which is 9. And the square root of 8 squared is 8. Therefore, my solution is 72. But I can still use the long way if I want to perform that task. Now I'm dealing with radicals and quotients. I'm allowed to have a radical in the numerator and just simplify that radical. What I'm not allowed to have is a radical in the denominator. When I have a radical in the denominator, I must find a way of eliminating that radical, but not to change the value of my quotient. To do that, we perform an operation called rationalization. That is when I multiply the top and bottom of this fraction by the radical that's in the denominator. Therefore, the square root of 2 is in the denominator, so I'll multiply the top and bottom of my fraction by the square root of 2. The square root of 2 over the square root of 2 is 1. Therefore, I can change the look of my fraction, but not the value. So let's perform this operation. 3 times the square root of 2. 3 times 1 is 3 square roots of 2. And the square root of 2 times the square root of 2 is the square root of 4. And that, when I simplify, is 3 square roots of 2. And in the denominator, the square root of 4. The square root of 4 is 2. And this is this fraction simplified. Here, I have 2 over 3 square roots of 6. Again, I'm going to multiply the top and bottom of my fraction by my radical that's in the denominator, the square root of 6 over the square root of 6. I don't need to multiply by what's outside the radical, just the radical itself. Now I simplify. 2 times the square root of 6 is 2 square roots of 6 over 3 times, and remember the shortcut, the square root of 6 times the square root of 6 is what's inside the radical, which is just 6. Therefore, I have 2 square roots of 6 over 18. Now I simplify my fraction, which is 2 over 18. And that will be the square root of 6 over 9. Here I have the square root of 5 over 2 square roots of 3. I'll rationalize, multiply the top and bottom by the radical in the denominator, the square root of 3. The square root of 5 times the square root of 3 is the square root of 15. Over, bring down the 2. The square root of 3 times the square root of 3 is the square root of 9, which we know is 3. Therefore, the square root of 15 over 6. And this does not simplify with the 15 since 6 is not in a radical and 15 is. Now, what happens if I have a situation where the fraction is all inside of a radical? I can rewrite that as the square root of 2 over the square root of 3. Then I just perform the operation as usual. I rationalize, I multiply the top and bottom by the square root of 3. That gives me the square root of 6 over the square root of 3 times the square root of 3, which is the square root of 9, which is 3. My next example, there are 2 ways to perform this. One, I could break this up as I did my previous example, the square root of 2 over the square root of 12, and then rationalize the square root of 12 over the square root of 12. That gives me the square root of 24 over square root of 12 times the square root of 12 is the square root of 144, which is 12. Then I must simplify the numerator. Therefore, the square root of 24 breaks into 2 factors, 4 times 6 over 12. The square root of 4 is 2 square roots of 6 over 12, which then simplifies to be the square root of 6 over 6. And again, this is simplified. I can't simplify this any further because one's in the radical and one is not. What I can do is, since these are both inside the radical, I can simplify this into a fraction of 2 over 12, which would be the square root of 1 over 6. Then that would be the square root of 1 over the square root of 6. In other words, this would be the square root of 1 is 1 over the square root of 6. Then I could just rationalize 1 over the square root of 6, multiply the top and bottom by the square root of 6. That gives me the square root of 6 over 6. Again, I'll get the same solution. You just have to determine which way you would like to perform this operation.